10.19. So, squids and octopi propel themselves by expelling water. They do this by keeping water in a cavity and then suddenly contracting the cavity to force out the water through an opening. A 6.5 kilogram squid, including the water in the cavity, at rest suddenly sees a dangerous predator. A. If the squid has 1.75 kilograms of water in its cavity, at what speed must it expel this water suddenly to achieve a speed of 2.50 meters per second to escape the predator? Ignore any drag effects of the surrounding water. B. How much kinetic energy does the squid create by this maneuver? Okay, so let's see. So we have the mass of the squid with the water in the cavity, which is m equals 6.5 kilograms, and the mass of the water in the cavity is 1.7 kilograms, and then the velocity of the squid after releasing the water is 2.5 meters per second. And then we know that the momentum of the system is the vector sum of all the particles that make up the system, and then we know that that the momenta of a particle is, and then we also know that this is a constant. Okay, so A, neglecting any drag effects of the surrounding water means that the system, meaning the squid and the water in the cavity, is considered isolated. So since the squid was initially at rest, so the momentum of the system before expelling the water is 0. And then the momentum of after is also 0. Okay, so first we should calculate the mass of the squid only as follows. So it is I just did, the overall mass minus the mass minus the amount of water in there, so it's 4.75. And then we plug in our values for what we have of the velocity of the squid and the mass of the squid. So we do P of S will equal the mass of the squid times the velocity. So that will equal 11.875. And then if we add up the system, we'd get the value we just found, 11.875 plus PW equals 0. So the PW equals negative 11.875. And now we plug in our values for PW and MW in the equation. So ultimately we get that negative 11.875 will equal 1.75 times this. So it'll equal negative 6.78 meters per second. So for the velocity of the water is 6.78 meters per second opposite of the squid. And that was just part A. So for part B, we use the values that we found for the mass of the squid and the velocity of the squid to get the kinetic energy of the squid. So we use this equation, 1/2 m squared v of the squid squared will equal 1/2 4.75 mass of the squid times the velocity of the squid, 2.5 squared, which will equal 14.84 joules. And then the values of the mass of the water and the velocity of the water to get the kinetic energy of the squid as well. I'm using the same equation as above. 40.29 joules. So now the total kinetic energy of the system is just adding this with this, and I get 55.13 joules for part B.